So here we are going to draw constant velocity diagram for a follow motion for both rise and return. Okay. So on the y-axis we take the lift, which is the maximum displacement of the follower, and on the x-axis we take angle of rotation of the cam, that is 360 degree. So I have taken here 36 centimeter as the angle of rotation of cam, which means 360 degree, and 7.5 centimeter or 75 mm as lift. Okay. Now the question will be rise of the follower is 100 mm, 100 degree, or it is called as angle of ascent. Then dwell at the maximum is 50 degree. Return of the follower 120 degree, which is the angle of descent, and dwell at the minimum is 90 degree. So for both rise and return of the follower, the motion is constant velocity. So first I am going to divide the x-axis, that is 360 degree, into 100, 50, 120 and 90. So for 360 degree I have taken 360 mm. So for 100 degree I will take 100 mm, 50 degree I will take 50 mm, 120 degree I will take 120 mm, and for 90 degree I will take 90 mm. So I have already divided it. So this will be my rise region, which is 100 degree. Rise of the follower is 100 degree. Then next one is dwell at the maximum, that is 50 degree. That is 50 degree. Then in the return of the follower, that is 120 degree. So this is 120 degree. And last one, dwell at the minimum is 90 degree. So dwell at the minimum is 90 degree. So I am dividing this section. Okay, I have divided all the section. So first section will be the rise of the follower. Second section will be the dwell. Third section will be the return of the follower, and last section will be the dwell. Okay. So rise of the follower means from the minimum to the maximum displacement is rise of the follower. Dwell means wherever it is, it will be like this. From here to here, it will be dwell. Return means from the maximum to the minimum, and again dwell. That will be the minimum region. Okay. So here constant velocity. So before drawing the constant velocity diagram, we have to divide this section into a smaller section for the drawing of the cam profile. So I am dividing this 100 into 4 equal halves. That will be 25 each. So I can show one. So this will be 25 like this. I have divided already this into 4 equal halves. Okay. Then I am joining using a vertical line. So here I will choose a lighter line. I am using a thin line. Okay. I have used a thin line. Okay. I have used a thin line. Okay. So I have divided this into 4 sections. So I have to give a number starting from 0. Always start from 0. This will be 1, 2, 3, and last will be 4. Okay. For constant velocity, it will be just a diagonal joining this section. Okay, it will be just a diagonal. For rise, it will be from minimum to maximum, and for return, it will be maximum to minimum. So for rise, it will be from minimum. From minimum means from 0 to where is the maximum lift. This point will be the rise. So this is the rise of the follower. Okay. So this is the rise of the follower. So I am marking the intersection between the vertical line and the inclined line as dash points. That is, if it is with the 1, it will be 1 dash. If it is with the 2, it will be 2 dash. If it is with the 3, it will be 3 dash. It will, if it is with the 4, it will be 4 dash. Okay. Now, so first section is rise. So constant velocity, the diagram will be just drawing the diagonal. So I have drawn the rise. Now it is dwell at the maximum is for next 50 degree. So maximum is this one. So this will be dwell at the maximum. There will be no follower displacement. Okay, the displacement of follower will be 0 at this point. 0 means it will not move from where it stopped. That is from 4 dash. It stopped at 4 dash. Then it will remain at 4 dash till the end of 50 degree. So I am drawing this as red. So our graph has reached till this point. Okay. Now I have to divide this 120 degree. So constant velocity division can be any way. So I have divided this into 4. Here I am dividing this into 5. So 120 degree divided by 5, it will be 24 degree. So I will show one section. Okay. Rest of the section I have already marked. Now I am drawing vertical lines. So I am showing this as thinner lines. That is the inside line. Okay. Now we have to start from here. Either you can give the number as 4 or you can continue the number. I will like to continue the number. So I am taking this as 5. This will be 6. This will be 7. This will be 8. This will be 9. And my last point will be 10. Okay. Now our graph has reached till this point. So this point will be 5 dash. Okay, I am marking this point as 5 dash. Okay. Now it is the return area, return of the follower, 120 degree or angle of descent. Return means from the maximum position to the minimum position. So maximum position is 5 dash to 10. So just draw a straight line connecting the diagonal. Okay. And mark the intersecting point as dash point. So this will be 6 dash. This will be 7 dash. This will be 8 dash. This will be 9 dash. And 10 it will be 10 itself. Okay. There is no displacement. 10 the displacement is 0. So this is the return of the follower. So I am showing it as red. Okay. So our graph has reached from 0 to 4 at the maximum. 4 to 5 dwell. It will remain at maximum. 5 to 10 return. Maximum to minimum. And then again dwell at the minimum is 90 degrees. So this region is dwell. Dwell means there will be no movement. So it has stopped at 10. Now there will be no movement. So the graph remains at this point itself. Okay. So first is rise, then the dwell, then return, then again dwell. Okay. Then the cycle again begins from here. So for our total rotation is 360 degree. 360 degrees over. Now it again start from this line. So this is how we draw constant velocity for rise and return of the follower. Okay, thank you.